184,000 people watched a single video telling them to stop learning n8n. This side-by-side data visualization shows a different reality from the exact same year. While social sentiment trended downward on the left, actual enterprise usage tells the opposite story. The platform's user base multiplied by 6, revenue grew 10 times, and over 80% of those workflows now involved AI agents. We have two conflicting data sets. The platform is simultaneously being declared dead by the community, while rapidly eating its own market in production. Both statements are accurate. The software isn't dying. The loudest voices are misinterpreting a massive architectural migration. I'm Bearded AI Guy. Today we are breaking down the work of the human architect who spent over 2 years building heavy automations in n8n before completely migrating away to code. Let's set the parameters for this analysis. We are not here to debate whether n8n is obsolete. It operates exactly as designed. The real engineering diagnostic requires us to isolate the specific kind of work that forced the transition. We need to find the exact architectural ceiling. To find that ceiling, we have to establish how automation history operates. A technological generation is defined by the default verb the builder manipulates. Track the progression. Macros manipulated sequences to repeat. iPaaS manipulated connections. Node builders manipulated logic graphs to orchestrate steps. Now, AJOs manipulate goals and constraints. You define the boundaries, and the system decides the path. Dropping a large language model into a third-generation tool does not upgrade it to an agent. It forces a rigid orchestration platform to attempt probabilistic decision-making. When you force probabilistic behavior into a visual graph, you see severe structural stress. Workflows experience massive latency spikes, and eventually the environments crash entirely. Real builders hit this wall in very specific ways. One user watched a 200-node execution ballooned from 3 to 23 seconds. Others reported page-unresponsive errors and Docker pods repeatedly restarting. Those are the surface symptoms. The underlying architectural flaw causing the system stress is state-passing complexity. Watch how a standard workload mutates. This starts as a clean 5-node support inbox router. To handle edge cases, the builder added bilingual prompts and sentiment priority. The graph exponentially multiplied into hundreds of overlapping routing lines. Adding those non-deterministic features creates catastrophic state-passing complexity. Every possible linguistic nuance or emotional tone requires its own explicit pathway, overwhelming the original design intent of the node. The visual graph doesn't crash because it lacks logical capacity. It crashes because the workload requires non-deterministic reasoning, and you are trapping it inside a deterministic container. This failure mode has led to a harsh consensus among heavy users. Spending hours memorizing the intricacies of individual n8n nodes is no longer the highest leverage skill for an engineer. Prominent voices in the space advise builders to cancel their subscriptions entirely, suggesting they learn Python or rely on frameworks like Claude Code instead. If we translate that social media advice into engineering reality, the conversation shifts from software preferences to structural layers. We are looking at an abstraction layer shift. The scarce developer skill is no longer manually mapping explicit API connections. The value is now in designing runtime boundaries and shaping the prompt architectures that govern an agent's behavior. Engineers are migrating because they would rather have code generate the low-level cloud functions automatically. This frees them to focus entirely on high-level capability design. There is a technical defense for keeping visual graphs. The most robust production systems in the world still rely heavily on visual orchestration platforms. For many builders, running simple, explicit visual automations will still outperform autonomous agents 9 times out of 10. The primary metric that justifies keeping the node graph is system visibility. This split screen illustrates the core risk of prompt-based agents. On the left, when an agent fails, it fails invisibly inside an opaque box, leaving 0 debugging trails. On the right, a sequential node graph isolates the exact point of failure immediately. Visual graphs provide granular, step-by-step observability. If a process requires strict auditing, governance, and human checkpoints, you need to see the exact execution path. Visual node tools have evolved from the default way to build everything into highly specialized observability devices. Every builder has to apply a strict binary diagnostic test to their existing workloads to determine which architecture to use. The first category is path mostly knowable. These are deterministic multi-system plumbing jobs and stable pipelines where every step is completely predetermined. Compare that to the environments that actively break visual platforms under load. The second category is intent must be interpreted. This covers open-text, multilingual inputs packed with overlapping edge cases. These workloads require dynamic recovery and probabilistic routing. Forcing probabilistic intent interpretation into a visual graph guarantees your maintenance costs will continuously skyrocket as you try to map every possible variation. The true boundary line in this industry is drawn strictly between deterministic paths and probabilistic goals. The generational shift toward agents is real, but it is significantly narrower than most content creators suggest. Visual graphs will continue to thrive because real enterprises will always require high observability deterministic flows. The ultimate failure mode is a builder using the wrong architectural tool for either side of that workload split. The migration to code didn't happen because visual graphs were useless. It happened because developers were using graphs for workloads that inherently required a brain. Drop a comment below with one of your workloads that belongs in the deterministic graph column and one that belongs in the probabilistic agent column. To read the detailed case studies behind this migration, check out the Human Architect's book, AI Agents in Action. In Day 7 of this series, we'll explore exactly what happens to your career and your role when you transition from n8n to Claude Code. Until then, look at your current architecture and ask yourself the only diagnostic question that matters.